So, a couple of housekeeping things before we jump into it here. So, this is the time of the semester, and I think maybe it didn't auto push this through. I'll try to be a little more conscientious in the future, maybe even double post it. So, if you get a repeated email from me, this is why. I posted an announcement earlier in the day yesterday. Some people didn't see it. Some of the one CL leader couldn't make it yesterday. So this is the time of year sicknesses, things like that happen. So keep an eye on the announcements on Canvas. I'll try to have them kind of auto push through to your email. Like I said, I'll double check this. I think I copied it over from the other section when trying to get it posted quickly. And I think it didn't send you an email, but it showed up on the Canvas announcements. So make sure you're kind of checking those, or if you show up, make sure, and there's no one there, make sure you're checking that Canvas announcement. But I'll try to make sure that I'm getting those pushed to your email in the future as well. I also put up an announcement yesterday, that Module 10 quiz, when I posted it, I apparently left or it didn't save kind of the due date. Hopefully at this point in the semester, we're used to every week. What should we do on Monday? The module quiz of the last week's material and the module reading for the next week. Just in case there was some confusion because it didn't show up on your dashboard or whatever it is, it didn't have that due date associated with it, I've extended the due date on that Module 10 quiz to be by the end of the day today. So if you didn't get that done yesterday because it was an oversight based off of that it wasn't showing up in your dashboard, you can complete that Module 10 quiz by the end of the day today, and it'll be kind of accepted, okay? So just to be fair, in the future, I'll triple check that I have that due date and then it saves when I post that quiz. But we should be used to kind of these due dates always being the same at this point, okay? Other than that, I don't think we'll use this Excel file today, so we'll probably just look at slides. We'll save this for next class. So we've got kind of Module 11 slides we'll start with. I don't think I have any other kind of class-related stuff unless there's any questions for me before we just dive into material here today. Okay? Nope, it's not what I wanted. There we go. So what we talked about last week, we can kind of think about as like our baseline or our jumping off point for today. So a perfectly competitive market is what's always going to be like what we compare to. So for the next 3 weeks, we're going to be looking at different types of markets, but we're always comparing them to what if this was a perfectly competitive market, okay? So this week, we'll talk specifically about monopolies, right? So how or why do monopolies exist? We have a couple different reasons, right? So we have 3 kind of different reasons we'll think about. One is maybe I own all of a key natural resource. So like I use De Beers diamonds as an example. They own not 100%. They're not quite a pure monopoly. But this idea of a monopoly, you've either played the board game or probably heard, it means that there is one firm. So if I own all of the diamond mines in the world, even if another firm wants to enter that market, can they? There's no other diamonds out there? No, right? So I might own a key resource, right? We said in a perfectly competitive market, what did we always have? If profits were positive, firms would want to enter, and there were no barriers to entry. So here we have, if I own a key resource, I'm essentially having a barrier to entry of that market. This isn't maybe, you poke holes in this example, but some companies, there's some things that there's only a certain number of people have the intellectual capability to understand. If I'm an employer in a certain market and I'm employing the only 10 people who have the intellectual capability to understand complex linear algebra and how it applies to data science and whatever. If I own a key resource of labor, that could also be a barrier to entry. There's nobody else who understands how to do this one thing. I'm employing all of them. So it doesn't just have to be a raw material. It could be a key resource of labor, right? The government might give rights. So like the post office, they kind of have this government issued right to do the mail service for the country. Essentially, they're allowing the post office to have a monopoly in that market. So the government can sometimes allow monopolies. I'll probably touch on this later on in class. But what's another thing that the government can do that gives only one company the right to produce something? They can give a company a patent, right? So kind of government issued patents also kind of create potentially monopolies, right? So it could be I own a key resource, the government kind of gives me exclusive rights, or once again, kind of bouncing off this idea we talked about last week, if I have positive profits, right? What did we say in a perfectly competitive market? If there's no barriers to entry, what might a firm want to do? There's positive profits being made. If I want to start a company, I want to start a company in that market. What does that do to supply? Increases it, which does what to the equilibrium price? Pushes it down, which would do what to profits? Lower them. Potentially, there are certain cost structures to where when one firm exists, that equilibrium price results in positive profits. As soon as a second firm enters, pushes that price lower, what could be true is that given the cost structure, that price is now resulting in negative profits, which means one of those firms is going to exit and we're back to one firm. That's the idea of a natural monopoly. Sometimes just the cost structure of a certain industry can lead to there only being enough demand to support one firm. This often exists at local levels. Electric companies, power line, that's a huge cost. So as soon as another firm tries to enter, that competition drives the price down low enough. Now there's negative profits. One would exit. We're left with one firm. So these natural monopolies can exist not because of like a government issued or a owning of a key resource, but just that there's only enough demand to support one firm. That's what's creating that barrier to entry. So these are kind of the reasons why these monopolies might exist. We want to try to understand these markets though. Okay. So when we go back to a perfectly competitive market, what did the firm's marginal revenue curve look like? We said when there's many firms, many producers, many consumers, each firm has to take what as given? The equilibrium price. They have no influence over it. That price becomes their what? So how do firms make profit maximizing decisions? When marginal revenue is equal to marginal cost, what did price become for the firm in a perfectly competitive market? Marginal revenue. So they face this kind of horizontal marginal revenue curve. We said it's like a gasoline. I can't get away with charging $1 higher for gasoline because what is everyone going to do? Just buy from the gas station across the road. Right? So with a perfectly competitive market, the demand curve that each firm faced was not all of market demand. It was a portion of it, and we couldn't get away with charging a price anything different than that equilibrium price. With monopolists, they are the only seller. So they're going to face the entire market demand curve. Okay? That will be their firm's demand curve. It'll be the same as the market demand because they're not splitting it with anyone. There's only one company. All right? So what's going to end up being true, and I could just tell you this, but we're going to have some support, is that the marginal revenue for a monopolist is not this horizontal curve. It's going to end up being the same as demand, but twice as steep. So we'll walk through a numerical table example why, and then I'll use some calculus, which you won't have to always reproduce, but just to kind of give you some further support why that's the case. So if I'm looking at a company, this different combinations of prices being set in quantity, that would be, if I graph that out, price quantity combinations would be my, if I lower the price, consumers buy more, so price quantity is my demand curve. If I graphed out price and the quantity that I'm able to sell, or the quantity demanded, that's just my demand curve. That's what we've been looking at. Right? So here, what's the slope of my demand curve? Every time quantity goes up by 1, what is price falling by? 50 cents. So I've got a slope of what? Negative 0.5, right? Now, if I want to calculate total revenue, we said before, what is the total revenue I'm earning? The price I'm selling the good for times the quantity I'm selling, right? So I could calculate total revenue by simply taking, if I lower the price, I'm going to be able to sell more units. So my total revenue is whatever that price I'm charging is times the number of units I'm able to sell. Okay? So that's all we're doing to calculate total revenue. Now, average revenue, just to kind of walk through some of these concepts before we get to the one that we really want to talk about. How would I find average revenue? It would be my total revenue divided by what? Quantity. Average total cost divided by quantity. Average revenue or average total revenue divided by quantity. So all I would do is take that total revenue divided by quantity. 4 over 1 is 4, 7 over 2, 3.5, so on and so forth. Now, if I want marginal revenue, this is where, yeah. Huh? Yeah. So why is my average revenue the same as price? Every unit I'm selling for The price of the good. So when I take price times quantity to get total revenue, and I'm producing Q, I would take price times quantity over quantity. What am I left with? The price. Because I'm just reviewing these concepts so we know how to calculate it when we change things. Yeah. But I mean, it will always be the same average revenue. If I'm selling every unit for the same price, it would be the same as that price, right? Now we'll get to models eventually where we talk about that won't always be the case. But the price I'm charging may vary, in which case we'll have a different average revenue. Yep. Now, what if I wanted to calculate marginal revenue? We've got to be able to, at this point, calculate marginal things. So if I want marginal cost, that's the change in my total cost divided by a change in. So total revenue is a change, or sorry, marginal revenue is a change in total revenue divided by a change in quantity. So if I think about here, what's the change in my total revenue going from 0 to 1 units? 4 divided by, I kept the change of quantity nice and easy here of 1, so 4 over 1 would be 4. 3 over 1 is 3. 2 over 1, so on and so forth. Okay? So notice what's happening if I, instead of graphing out demand, I graph out at the different quantities what my marginal revenue is. As I produce one more unit, how much is my marginal revenue falling by? $1. How much was my price falling by, or what was the slope of demand? 50 cents. So my marginal revenue curve is twice as steep. Right? So we can use these numerical values to kind of prove this to ourselves, or, and I'm jumping the gun here, I think I've got a slide later on, we'll probably just revisit it, but I think at this point it makes sense to kind of go through it right now. If I'm thinking about a demand curve, we could go all the way back to module 3 and said that was really just price as a function of quantity. Okay? So if I want total revenue, what is that? Price times final exam average is not going to be great if we can't answer these questions, right? Price times quantity. The price I'm selling the good for times the number of units I'm selling, that is my total revenue. Okay? All I'm going to do here is, where does this price come from? Well, I have a demand curve, which is if I want to sell a certain number of units, this is the price I have to charge. So I'm just going to plug in for price that demand curve. Multiply by quantity. I'm just going to rewrite this just to maybe help with the calculus. Because if I think about marginal revenue, we said marginal revenue is a change in total revenue divided by a change in quantity. All of you should have to get in this class, your math background should be good enough to understand. If I want the change in something coming from a change in another variable, what is that? Starts with a D. I would take a function, I would take a derivative, right? That's telling me the rate at which total revenue is changing by, or it's telling me my marginal revenue. So my marginal revenue here, if I take a derivative of total revenue in respect to quantity, what am I left with? A plus 2 times B times quantity. So notice my marginal revenue curve starts out at the same point as demand, but it is twice as steep. That's where that comes from. If you just want to memorize that, and as we draw these visuals, just always remember marginal revenue is twice as steep as demand, that's fine, but I'm giving you the support as, like, I'm not just making this up, right? Because marginal revenue is simply just the change in total revenue over a change in quantity. That's taking a derivative of this total revenue curve. It would always give me the same point that demand starts out at, but twice as steep. Okay? So if I'm thinking about what this visual would look like as we start to kind of build this out, at different quantities, here's my demand curve. It starts out at some intercept value A. My marginal revenue curve will always start at the same point as demand, but be twice as steep. Okay? So that's what we're going to kind of start. It's our kind of base is our starting point. Okay? Any questions? I'm not going to make you have to reproduce this or anything. I'm just giving you some support behind why. Okay? Just kind of might make sense to some of you more than others. Okay? If you want to, you can rely on, you could go through actual values and prove this to yourself, right? We had an original slope of the demand of -0.5. Our marginal revenue curve then ended up with a slope of -1. Now, if I'm a company and I'm producing, what do I want? I want my revenues to be higher and my costs to be lower. As I start to produce more, what is that going to require? My costs are going to go up. So if my costs are going up by producing more, what do I definitely want to be true? That my revenues are also increasing and hopefully increasing by a larger amount. So if I'm looking here, which of these quantities do I definitely not want to produce? Even without any information about what my marginal costs are, which of these would I definitely not want to produce? Yeah, a quantity of 6. Why? Because my marginal revenue is there. If I produce going from 5 to 6, what's happened to my revenue? If marginal revenue is negative, my total revenues have went down. I know that by producing more, my total costs have to go up. That's not going to be a good thing for profits. Right? So I know that firms are going to definitely want to choose somewhere where marginal revenue is positive. Right? Now, from there, we can start to think about, well, where do I want to be at? Right? So I'll kind of show you out here. I've got like a different depiction. If you try to do this, there is a weird thing I wanted to mention that can happen. If we have like integers and we don't have like a fully complete table, I draw always as it starts out at the same intercept. You're technically going to have a weird thing going on at the quantity of 1 if you graph this, because there is no marginal revenue at 0. Like there's no change that we can't go from negative production. So if you do graph out these points, you might end up with this weird thing where it kind of looks like the intercept is at that quantity of 1. But that's just because we can't calculate a marginal revenue at 0. If we had a truly infinitesimal amount of quantity values, here's kind of the way you can always depict it, right? And the way that you should always be thinking about it, right? At that very first infinitesimally small increase in quantity, you're going to start out at the same point for demand and marginal revenue, but marginal revenue is falling twice as steep, okay? So this can happen when we have these very kind of simplified models with really small quantity jumps, okay? So marginal revenue is decreasing and twice as steep as demand. So let's start to think about what's marginal revenue really capturing. If I lower the price, if total revenue is price times quantity, is that a good or a bad thing for my total revenues? If I lower the price, that's going to do what to my total revenues? Decrease it. So we would kind of say that is our price effect. But as I lower the price, I can convince consumers to buy more. So my output effect would do what to total revenues? Increase it. Which of those do I want to be larger? If I'm lowering the price, that's bad for total revenues. I hope that my output effect is larger than my price effect, okay? So if I've got these two kind of competing effects, oops, I hit the wrong arrows, right? I'm hoping that my marginal revenue is going up and that output effect is larger than the price effect. So I'll give you a different way of thinking about this here in just a second. But kind of with this idea in mind that we have these competing effects. As I lower the price, I'm selling more units, okay? We'll get back to this, right? But it's going to be directly related to our marginal revenue curve will be related to elasticities, okay? So let's think about why, okay? So let's think about my total revenue. It's price times quantity. So if I then think about as I lower the price, what's happening to my total revenue? Or essentially, what is the marginal revenue from that effect? Well, if I lower the price, right, that means I'm going to increase the number of units I'm selling. So which of these do I hope is larger? The one that is increasing total revenues, or I hope that my output is greater than my price effect. If I instead think about marginal revenues, the change, or I could think about the percentage change in price as I lower the price, that's going to be part of how my total revenues are changing by. But the other side of that would be, what is that percentage change in quantity demanded? So what am I really hoping for here? If marginal revenues are positive, what must be larger? That output effect. So what I'm really saying is, when marginal revenues are positive, that percentage change in quantity has to be larger than the percentage change in price, or the output effect is greater than the price effect. What's my elasticity of demand? Percentage change in quantity over percentage change in price. If my numerator is higher, my elasticity will be greater than what? If the numerator is greater than the denominator, this fraction has to be greater than 1. Or what is demand? This is where it's not cumulative, but we're going to be using topics we've already talked about. If we have an elasticity measure greater than 1, which we know will be the case if marginal revenue is positive, because that percentage change in quantity or the output effect would have to be greater than that percentage decrease in price or the price effect. So anytime I've got positive marginal revenues here, what's going to be true about the demand curve? We said the elasticity is greater than 1, or anytime marginal revenue is positive, I'll be on the elastic portion of our demand curve. Well, we said we know firms don't want to be on that marginal revenue where it's negative because I'm just lowering my revenues. Profits are definitely going to go down. So when they choose the optimal quantity, where will firms always be at on their demand curve when we talk about monopolists? Well, we know they're going to choose somewhere where marginal revenue is positive, so they're always going to be on the elastic portion. Okay? You could walk through the kind of the same idea. If marginal revenues are instead negative, what must be true? Well, that percentage change in price must be greater than the percentage change in quantity, or the price effect is greater than my output effect, which would mean that my elasticity of demand, well, now my denominator is larger, so this fraction would be less than 1, or when marginal revenue is negative, I know I'm on the inelastic portion of my demand curve. Okay? All right? So I always, how can I be raising my profits if I'm lowering my total revenues? Because as I produce more, I know that my costs have to be going up. So if my costs are going up and my revenues are going down, I know that when I've got inelastic demand, I'd always be reducing my profits. So the only points where profits can be maximized are somewhere on that positive marginal revenue curve. Yeah, so what would have to be the unit elastic point here? We said unit elastic means that my elasticity of demand is equal to what? 1. So that would mean the percentage change in price would have to be what? Equal to? If my price effect exactly offsets my output effect, what's the change to my total revenue? Nothing. So when my marginal revenue is equal to 0, that's where we would be at that unit elastic point. Yep. Okay. So this is kind of thinking about where we'll be at on that demand curve for the monopolist. Because they face this twice as steep marginal revenue curve, they're always going to want to end up somewhere where marginal revenues are positive or on the elastic portion of their demand curve. Okay. Any questions on this idea before we keep moving? And we'll kind of solidify this a little bit more, I think, in a second, why they end up at a point where marginal revenue is positive. So this is kind of a similar graph that we drew out, just kind of I pieced it together a little bit more, right? So we kind of have this idea of elasticities and revenues here. Now, one thing I didn't do for the other section, but I think I'll do here, kind of revisiting something that we talked about way back in Module 4. What did we say if we're thinking about the elastic, inelastic, and unit elastic point? So if these are the different quantities and prices I have, if I'm graphing out total revenues, do we remember where are total revenues maximized? At that unit elastic point. Because as long as marginal revenue is positive, my total revenues by selling more units has to be going up, right? So we don't know exactly where the profit maximizing quantity is going to be, but it's going to be somewhere where we're still increasing total revenues. It'll never be over here on that portion where total revenues are decreasing or where we have negative marginal revenue. Okay? So we kind of already looked at these graphs way back in Module 4. Okay? All right. So before we go to the slides, well, I guess we're on the slides here. So I'll set this up a little bit and then we'll do some more drawings here. So what did a perfectly competitive firm do? It set the profit maximizing quantity where marginal revenue is equal to marginal cost. The monopolist is going to do the exact same thing. However, they don't face kind of this constant marginal revenue curve. They face one that's twice as steep, right? So how are they going to figure out, with a monopolist, they're not taking the price as given, they're setting the price, right? So how are they going to set this price, okay? So we'll think about what this model looks like and hopefully answer the question by the time we're done. So here I've got quantity, price, I've got my demand curve, I got my twice as steep marginal revenue curve, okay? Now, I'll start out with what looks more like a realistic scenario and then use another one just to kind of make a point. So let's say what's typically happening, or at least as we produce enough units, what happens to marginal costs? As we produce more, marginal costs start to increase. We can have this initial like diminishing marginal costs where we have gains from specialization. But a more kind of simplistic way of drawing it is we think about eventually we know marginal costs are going to increase. Okay? So where is the profit maximizing quantity for the monopolists? Well, they're going to set the quantity where marginal revenue is equal to marginal cost. They don't face this horizontal marginal revenue curve. They face one that's twice as steep based off of what demand for that product is. So this would be kind of like our profit maximizing quantity for the monopolist. Now, what tells me how much the consumer is willing to pay? They'll pay up to whatever their marginal benefit is. What represents consumers' marginal benefits? The demand curve. So once they choose or figure out what the profit maximizing quantity is, what price would result in that quantity? Or how much could I get away with charging consumers at that quantity is another way of thinking about it. Well, the demand curve tells me they're willing to pay up to this amount, so that's how I'm going to set the price. So there's kind of a second step for a monopolist compared to like a perfectly competitive market. We identify the profit maximizing quantity, but now we're not taking the price as given, we're setting the price. So what do we set the price at to get that desired quantity? Whatever point we'd be at on the demand curve. So we find that profit maximizing quantity where marginal revenue is equal to marginal cost. Nothing's changed there. But we then go up to the demand curve to set that price. So the price is always going to be what? Above our marginal revenue, right? It's always, we're going up to the demand curve. If marginal revenue is twice as steep, we're always going to be going up to the demand curve to figure out what that price is, okay? Any questions on this idea before we keep moving here? Okay. So, oh, it's not what I wanted. There we go. So basically what I just drew out, we identify that quantity where marginal revenue is equal to marginal cost. We go up to the demand curve to then find out what that price is. Okay. So if I wanted to compare this to a perfectly competitive market, this is kind of a summary of what will happen. Well, let's prove to ourselves why. Right? So I'm just going to draw this model out again in a slightly different way to kind of help us think about comparing the monopoly market to a perfectly competitive market. So if I have a perfectly competitive market, here's my market demand curve. Now, if I have the marginal cost of the firm, if there's only one firm, right, what did we typically think of supply curve representing? I write it next to supply almost every model. Supply is equal to marginal cost. Well, it's really the sum of all the firms in that industry's marginal costs. But if I only have one firm, that firm's marginal cost simply becomes my supply curve. Right? So if this was a perfectly competitive market, profits are equal to zero at whatever that equilibrium price in the market was, right? So if I had just a market, this is like any market we're thinking about, what is the equilibrium quantity and price? Simply where supply would be equal to demand. So that's kind of our baseline, right? This is where the perfectly competitive market would arrive at. That long-run equilibrium where the supply curve is equal to the demand curve. The kind of nuance here is that our supply curve would simply be the firm's marginal cost curve because they're the only firm. They're the only ones supplying this good. Okay? Now, if I think about the monopolist, they're going to choose the quantity in this market by doing what? Setting quantity where marginal revenue is equal to marginal cost. You're going to get tired of hearing me say this. But their marginal revenue curve is what? Starts out at the same point as demand, but is twice as steep. So notice, anytime marginal costs are anything, the point where marginal revenue is equal to marginal cost, I could even if it wasn't twice as steep, just think about like a barely steeper curve. It's always going to be hitting marginal cost at a slightly lower quantity, right? Now, if it is twice as steep, it's definitely going to be hitting it at this lower quantity, okay? Now, that doesn't mean, so just so we don't get this confused, if a perfectly competitive market quantity is 100, the fact that our marginal revenue curve is twice as steep does not mean the monopolist will choose 50. That does not mean that it's half of whatever the perfectly competitive market chooses. In fact, depending on what our marginal costs are, notice what's happening to the gap. You can kind of think about this. What's happening to the gap in between demand and marginal revenue? It's getting larger. So depending on where my marginal costs are, that difference between the quantities could be a variety of different values. So just because it's twice as steep doesn't mean the quantity the monopolist chooses is half that of the perfectly competitive market. We only can say that it will be lower, okay? Now, what can I say about the price? Well, how do I figure out the profit maximizing price for the monopolist? I look at that profit maximizing quantity and I do what? I go up to the demand curve. So if I'm going up to the demand curve, what will be true about that monopoly price? It is always going to be greater than that perfectly competitive price. Okay? So we can always say these two things are true. So kind of that's our visual depiction that in a summary says the monopolist will always choose. So if I'm looking at a multiple choice question and I'm comparing these two markets, the quantity the monopolist chooses should always be lower, and the price they set compared to a perfectly competitive market should always be higher. Those have to be true. Okay? Any questions there before we keep moving? Okay. All right. So where do we want to go from here? We kind of already talked through this idea of marginal revenues. So I jumped the gun earlier and kind of gave you the support as to why marginal revenue is twice as steep. So we kind of already worked through this calculus, kind of think, so we can kind of continue. We've already talked about this. All right. So if I'm thinking about these monopolists, if I had the visual in front of me, this is where like people keep asking me, and I know I've said this in class, what is the best way to study for the final or for these quizzes? Look at the practice questions and do what? For every problem, draw out a solution using a graph, or now sometimes maybe using equations. This one maybe become kind of difficult to answer, or I can make easy mistakes if I don't have a nice visual in front of me to keep track of things. So if I'm thinking about what for the monopolist is going to be true about price, marginal revenue, and marginal costs, if I get used to drawing out what the revenue marginal cost curve for monopolist looks like, I hopefully can very quickly see what is true about the marginal revenue and the marginal cost. If I'm profit maximizing, those should always be equal. What has to be true about the price? It has to be above those two things, right? So hopefully, it doesn't matter if this was a monopolist or a perfectly competitive firm. Which of these answers should we be able to rule out right away? At the profit maximizing quantity, what is always equal to what? Marginal revenue is always equal to marginal cost. That'll be true in all the models we look at. So right away, we should be able to rule out B and D. Now with the monopolist, right, we said they go up to the demand curve to set the price, so the price should be above whatever that marginal revenue and marginal cost values were. Okay, so their marginal revenue will be equal to marginal cost, and that price will be above both of those. Okay. Now let's think about trying to use a table instead of kind of using graphs. Right? And this is where the graph could still help us. So let's say I have a constant marginal cost at 5. I'm making this a little bit more simplistic because it makes it easier to solve this, right? So I could kind of give myself a quick visual where here's my quantity, here's my demand curve, here's my marginal revenue curve, here's that constant marginal cost equal to 5. So what am I really looking for? I'm looking for the quantity, right, for this monopolist where marginal revenue is equal to that marginal cost of 5. Now, if I gave you this table without the marginal revenue column, I might do that on the quiz this week. I wrote the quiz, so I probably know, right? How could I recreate these marginal revenue values? I would simply look at change in my total revenue divided by a change in quantity. In fact, I could leave off the revenue column. How could I still get my marginal revenue? Well, what is revenue? It's price times quantity. So I could then do that to fill out that total revenue column. Now that I have total revenue, I can calculate marginal revenue by, well, what was the change in revenue going from 0 to 5 units? 45 divided by a change in quantity of 5 gives me that marginal revenue of 9. And then as I increase quantity from 5 to 10, my revenues changed by what? 35. 35 divided by that change in quantity of 5 would give me a marginal revenue of 7, so on and so forth. Okay? So if I have a constant marginal cost of 5, monopolist or perfectly competitive firms, I will choose to produce something if the marginal revenue is greater than or equal to my marginal cost. So for those first 5 units, will I want to produce those? 9 is greater than 5. Marginal revenue is greater than marginal cost, so yes. What about the next 5, going from 5 to 10? Well, marginal revenue is 7, still above my marginal cost of 5, so yes. What about going from 10 to 15? Well, marginal revenue is exactly equal to, so I would say going from 10 to 15, I am indifferent, or I would choose to produce up to that point. What about going from 15 to 20? Well, now my marginal revenue is 3. That's actually below my marginal cost. If my revenues are going up by a smaller value than my costs are increasing by, what's going to be happening to my profits? They're going down, right? So I'm only going to produce up to that 15th unit, okay? Now, I didn't ask the question here, but I could. What price would this monopolist then set? So this is where sometimes having the visualization, well, if I just found that the quantity is going to be at 15, how do I find the price? I go up to my demand curve. What is demand? It's this, just the combinations of the price and quantity combinations that we have. So once I solve for that quantity of 15, what price do I set? All right, looks like not 6. What is the price at the quantity of 15? 7. So the price the monopolist would set would be 7. The price or the point that I'd be at on the demand curve at that profit maximizing quantity. Okay? Any questions there? We're going to throw in some additional things here, so make sure you're asking now so we don't get kind of fall behind here. Okay? Yeah. Well, I probably went through it just now because I could ask you to find the price, right? If I can solve for the quantity, all I have to do to find what that price the monopolist sets is look at that quantity and look at the corresponding price. All I'm doing by looking at this difference of price and quantity, that's what I'm doing when I say find the quantity first and then go up to the demand curve. Because the marginal revenue value at a quantity of 15 was what? 5. What is the price at that quantity of 15? Well, there I have to go and look at the price, or I have to go up to my demand curve at that quantity of 15, the price that would correspond to that quantity would be 7. So that's how the monopolist would choose their price. Yep. Any other questions before we keep moving here? Okay. All right. So what if I had a marginal cost of 0? So this is where there won't always be an equal point, right? But if I had marginal cost of 0, which of these units would I choose to produce? As long as the marginal revenue is above 0 or above the marginal cost of 0, so I would produce the first 5, 10, 15, 20, 25. Would I produce the 30th? Well, the marginal revenue is negative. That's going to be below the marginal cost of 0. So no, I'd stop at 25 units. Similar kind of idea. Notice with these kind of constant marginal, okay, if the quantity is 25, what price would I charge? Whatever price would kind of be point to be out on the demand curve, with a quantity of 25 would be a price of 5. So if my costs are lower, intuitively, what did the firm do? It chose A. So before we said they chose how many units? 15. Now they're choosing 25. So when my marginal costs are lower, that profit maximizing quantity is going to be higher. There's going to be units before where I was earning negative profits. The marginal revenue was below marginal cost. We're given these new lower marginal costs. Those units might now have positive profits. And it's kind of intuitively, if my costs are lower, I'm going to want to produce more than I was before. Okay. So I kind of identified this on one graph, but you can kind of make this connection between thinking about that one firm's marginal cost curve essentially becomes our supply curve. So that perfectly competitive point will simply be where the demand curve is equal to the supply curve, where if we have one firm, their marginal cost curve is the supply curve. So when we're drawing this out, sometimes I might not draw this as a purely linear supply curve, because if it is the firm's marginal cost, what could be happening? We could have initially gained some specialization. So we would still kind of look for where does that marginal cost or supply curve hit the demand curve to identify that perfectly competitive price and quantity. But when we're thinking about the monopolist, we said they'll choose the quantity where marginal revenue is equal to marginal cost, right? That's going to be at a lower quantity and a higher price. It's just a different depiction of something that we've kind of already looked at, right? So we want to be able to have this comparison in mind, especially next class. We'll kind of do a little bit with it here today before we leave. But next class, when we start to talk about welfare implications, notice if the monopolist ends up at a lower quantity than the perfectly competitive market, well, what's true about surplus in this market where supply is equal to demand? That's where total surplus in the market should be maximized. So if I move away from that point, before we talked about this with taxes or subsidies, well, now if I move away from that point because I have a monopolist, well, if I move away from that perfectly competitive quantity, what am I going to now have? What did taxes, subsidies, price ceilings all cause or all create? They didn't create externalities, right? All of those tools we had created in the market, deadweight loss. So monopolies were essentially going to create deadweight loss for us. Okay. All right. So we kind of can identify these points. We'll now start to think about one more thing, which is how do I calculate monopoly profits today? Okay. So if I can identify the quantity and the price, what's the only other thing that I need? Okay. So I've got some stuff in the slides. I'll sit here and kind of draw out a few for us. I think that'll help make a little more sense of it. So let's start out with one model where I'm thinking about, I've got this demand curve. I've got my twice as steep marginal revenue curve. Here's my marginal cost curve. And I'll start out with one that's a little bit more of a realistic scenario. And then I'll do another one to kind of make a point. So here's my average total cost curve. Marginal cost, I tried to draw it, right, is hitting it at its minimum point. Cost structure over monopolist looks exactly the same as it did for these perfectly competitive firms, right? U-shaped average total cost, marginal cost hits it at its minimum point, right? Now, I'm only going to depict long run. I'll talk through the intuition behind short run probably later on today or definitely next class. But for right now, let's just think about long run, okay? Well, where is the profit maximizing quantity going to be for this monopolist? where marginal revenue is equal to marginal costs, right? So the quantity the monopolist chooses is going to be right here. How do they set the price? They go up to the demand curve because that reflects how much the consumer is willing to pay at that quantity. So here's that price, here's the quantity. What's our profit equation, or one form of it that we talked about last week? It's the quantity I'm selling times the difference between price and average total cost. So what if I have quantity, I have price, what's the only other thing I need? What is that average total cost value at that profit maximizing quantity? Once I have those three pieces of information, I can calculate the profits for this monopolist. Notice, if I think about this rectangle, what's the height? The difference between the price and the average total cost of the monopolist. What's the base? The number of units they're selling. This rectangle would represent monopoly profits. If price is above average total cost, my profits here are what? We've got to be able to look at this difference and determine what's happening. If price is above average total cost, profits are positive, right? So if I didn't have any barriers to entry, what would firms want to do? Enter this market. If I have barriers to entry, maybe it's a patent, maybe it's I own a key resource, I can actually have positive profits because I can prevent other firms from entering. Okay? So we already figured out how to identify those two key pieces of information to calculate profits. The only other thing we need is our average total cost curve. And then we can calculate the profits of the monopolist. Okay? Any questions on this idea? I'm going to draw something else out that might be a little bit weird. So let's assume I had a similar model, right? I've got my demand curve. I've got my twice as steep marginal revenue curve. I've got my marginal cost curve up here. Got my average total cost curve. Okay. Where would the monopolist set the profit maximizing quantity where marginal revenue is equal to marginal cost, right? They then would do what to set the price? Go up to the demand curve, right? Now, once again, just as a reminder, our profit equation is the difference between price and average total cost times the quantity we're selling. Right? So at this profit maximizing quantity, what's true about the difference between the price and the average total cost of the monopolist? The price is less than. So this would be my profits. But if price is below average total cost, my profits for the monopolist here would be price is above average total cost. This value would be negative, right? And you've got to be able to look at a difference and know if it's positive or negative, okay? So if I have negative profits, what is this monopolist going to do? Exit the market. If he exits the market, what are we left with? Nothing. The entire market would go away, right? So if there is ever an industry like, I don't know, maybe movie theaters is a bad one, but I drive by enough like vacant movie, or we go to the mall, all these like huge department stores, they're all like gone now. What happened? Even if they had a monopoly in the market in that small town, the demand wasn't high enough, negative profits. If I'm the only department store in that city, if profits become negative and I leave, what are they left with? Nothing, right? So we know that if we have a monopoly exist, what are their profits going to have to be? Positive, because if they're negative, what do we see? No market, right? There won't be one, right? So when we talk about monopolists, as long as we have one of those three things we talked about that ensure that they can remain a monopolist and it doesn't become a perfectly competitive market, we know their profits would be positive. Now, I sometimes get questions or a little bit of pushback at this point. Yeah. Do the monopolists care that there's a negative? Well, that's a whole different story, right? If we have negative profits, well, if we want to make sure that that industry stays, what would I have to do? Subsidize it. But that's, I'm saying if the government, we haven't talked about government intervention, right? Just will the monopoly exist on its own? No. In fact, if I want the post office to exist, what am I likely going to have to do as the government? Subsidize it. Because if I didn't, what do you think their profits probably are? What are they going to do? Exit that market. Right? So yes, we can do different combinations. I'm not, we're solely just focusing on monopolies. Next class, we might talk about kind of government policies related to monopolies, but for right now, we're just thinking about just the monopoly existing. Does that answer your question? Now, I might also get pushback at this point because if you look at the accounting, of firms, they might show that they have negative profits. So if we're thinking about the long run, this is where it kind of goes a little bit outside the scope of this class. When we talk about these demand curves, we're really thinking about them as projected demand curves. So let's think about this thought experiment. Let's say electric vehicles, go back 20 years. Did people trust them? Not as much. So what was true about demand? Relatively low. Even if I was the only producer of electric vehicles, my profits would have likely been negative. Why might I have started in that industry? Why did Elon Musk put all this money into developing, Tesla? Even though profits might be negative for the first 5 years, what do I hope happens? That demand increases by a lot. If demand increases by a lot, what also increases? My marginal revenue curve. Now I might end up at a point where the price is above. Now, if the profits over the next 20 years are greater than those losses in the first 5, now maybe I would choose to enter that market. So in practice, really what we would do there to make the decision about if we wanted to join that market, you would be looking at somewhat of a weighted average between how many years you expect demand to be low versus high. But ultimately, the only way it would make sense for a monopolist to exist in a market with negative profits is if we weren't looking at the long run. That potentially in the short run, they're earning negative profits, but they expect, if nothing changes, then yeah, eventually they're going to leave. They have to be expecting that there would be demand changes in the future if they remain in that market, right? I won't push you as far about of those expectations, but in terms of the real world, that's what we might see happening, okay? Does that, I kind of said that quickly, but I just, like I said, I want to try to make these connections. Sometimes this would be outside the scope of what I would expect you to know for the quiz or the exam. I just want you to think about if we have positive or negative profits, monopolists still make this decision. If profits are negative, I exit the market without government intervention, right? And if I have positive profits, I would choose to remain in the industry. So what is this going to look like, right? We set that quantity, we identify the price, we can then look at the average total cost and then calculate profits. We now have the 3 things we need to calculate profits: quantity, price, average total costs. Okay? Yeah. Yep. But we haven't talked about it today. So if you look at the slides, Thursday we'll talk about it. Yep. Yeah. So we'll get to all the government intervention stuff next class. Okay. There's one other thing before we do this quiz. Let me think if I want to do it before or after. I'll do it before. I think that this helps some people think about why our profit equation is what it is, and not simply memorizing it, but being able to kind of think about why this is our profit equation. So quantity is going to be the number of units that we choose to sell, right? If I'm setting the price, every unit I sell for the same price, how could I think about my price? It's my per unit what? Well, if every time I sell a good, the amount of money I make is whatever price I charge, price is really like my per unit. What do we call the money I earn from selling something? If you guys want to be in Kelly, we got to be able to answer this. If you sell something, what are you making? Revenues. You're making that's your revenues versus your costs, right? So my price, if that's how much I'm selling every unit I'm I'm selling every unit for this price. That is my per unit revenues. What is my average total cost? I've mentioned this before. Another way to think about that, it's my per unit costs. Going to a basic accounting class, what are my profits? Now, we have different forms of the equation, but what would profits simply be at the most simple way of saying what profits are? You take your total revenue and you subtract your total costs. So if I'm looking at the per unit differences between my revenues and costs, what's another way I could think about what that difference would represent? It's my per unit what? Revenues minus costs will be your profits, right? We want to think about what companies are doing. Profits are the difference between your revenues and your costs. So the difference between my per unit revenues and my per unit costs, what does that represent? My per unit profits. If I take that and I multiply it by the number of units I'm selling, well, if on average I'm making $20 in profit for every unit I sell, and I'm selling 20 units, what's my profits? 20 times 20. Right? So that's another way of thinking about why this equation is giving us profits. It's the per unit profits we're making multiplied by the number of units that we're selling. Right? That's simply going to give us the value of what our profits are. Now, if you want to just memorize that equation, it's quantity times the difference between price and average total cost, you can. But if we think about what is that price, it's how much money we're making when we sell something. That's our per unit revenues. Average total cost, we've determined on average what is our per unit costs. That difference should represent our per unit profits. So just a different way of thinking about that profit equation, maybe a way to remember what that equation is, as opposed to like just rote memorization. So we're going to be using this and then kind of thinking about how do we use visual depictions to then solve for those profits. Okay, so let's look at this quiz here. I'm going to change it. I think I had it set to be a little bit earlier, so we'll do, I don't know, just give people plenty of time here. So it should show up on the home page or under the quizzes tab or even under the modules tab. So we'll come down here, look at quiz 11.1. I believe the code should be 57.56. So 57.56 should get us into this quiz. Those are the average temperatures of yesterday and today in Bloomington, Indiana. We are far from that, right? So 57.56 is that number that gets us in, okay? Now, hopefully, and I get that this is the first day we've talked about it, so I'm not saying you should understand it today. But this is a question that will I can guarantee you there'll be a question like this on the final exam. This has got to be an easy question on the exam. It has to be, as you're studying, right? If I've got a model, how do I identify the profit maximizing quantity and price of a monopolist? Okay? So how are they going to solve for the profit maximizing quantity? It will be where what is equal to what? Marginal revenue is equal to marginal cost. These jumps are quantities of 5. So marginal revenue is equal to marginal cost at a quantity of what? 15. At that quantity, how do I determine what price would result in that quantity being sold in the market? I would go up to my demand curve. So that corresponding price, or the point I'd be at on the demand curve, looks like it's right there at 35. So the optimal quantity would be 15, and the price that would result in that the monopolist would set would be at a price of 35 there. Okay? I've got to be able to, from a visual representation, identify that profit maximizing price and quantity. And today we haven't made the distinction, but technically after Thursday's class, this is for a single price monopolist. All we're talking about today is they're setting a single price for this good. Okay? We'll talk about some variations of monopoly models in Thursday's class. Okay? Any questions over that idea? So you can expect to see a question just like this on the quiz this week and just like this in the final exam, right? Any other questions? Okay. Everybody getting into the quiz okay? Yes, no? Okay. So we didn't have Wi-Fi issues in the first section, so I'm guessing it's a little better today. Same visual representation. If I want to calculate profits, I'm already 2/3 of the way there because we just said what was the quantity that the firm is going to choose? 15. What was the price they were going to choose? 35. The only other thing I need is what? At that profit maximizing quantity, what is the average total cost? So what would my average total cost be at that quantity of 15? Looks like it's right there at 25. So average total cost is 25. So I can think about, this is where it might help to think about it this way. I can plug the numbers in and enter it into my calculator. But what's my per unit profits here? On average, every unit I sell, I'm selling for $35, but it costs me $25. My per unit profits would be $10 times the number of units I'm selling, 15. My profits should be 150, right? Now that's where if I like forget parentheses in my calculator, I'm not going to get 150. I might get the wrong answer. But if I think about this as what is my per unit profits, or what's that difference between price and average total cost? On average, I was making $10 per unit, selling 15 units. My profits there would be 150. Okay? Any questions on that one? Okay. Let me think if there's anything else I want to say here. I think that should be good. So we've got what? The only other thing I want to mention here is if I think about why this is the profit maximizing quantity and price, I could choose any other quantity. And if I look at the difference between, like, for example, let's choose this. If I sell 20 units, what's the difference between average total cost and the price I would set? What? So the price is 30. Average total cost is 25. So 5 times the quantity of 20, I'd be making profits of 100. That's less than 150. There's no other point I could choose where I'm going to be able to calculate a profit level that is greater than 150 if I've identified this correctly. Okay. Any other questions over anything on this quiz before we got some other stuff we'll kind of talk about to end class today? So I think I had it set to be 12:15. So get it submitted within the next 2 minutes, 3 minutes, and we should all be good. Okay. Everybody good with that? I'm hearing a lot of murmurings. Something going on I'm not aware of? We're good? Wi-Fi's it? So people are having issues, get it submitted? Say yes. No? Everyone's good? Were we able to get it submitted? Okay. Yeah. Oh, you're just raising your hand to show something. Okay. All right. So kind of we'll start to think about kind of monopoly versus perfectly competitive firms in the long run. I'll probably skip this for now. We'll kind of think about this depiction a little bit more next class because I want to make sure we have time for as that we start to think about kind of identifying some of the welfare implications of monopolists. So, well, I can kind of touch on the other topic. I think we have enough time. So let's say I'm thinking about a market, right? I've got my demand curve. I've got my marginal revenue curve. And here's my marginal cost curve. And what I want is that if I am thinking about the long run, what should be true? So now we're kind of going back to perfectly competitive markets. In the long run, the equilibrium price of the market should put me at what point of my average total cost curve? So profits were 0, and in the long run, it pushed companies all the way to the lowest possible point on the average total cost curve. So notice, when I have one firm, their marginal cost would be supply. So that kind of perfectly competitive quantity should be where supply is equal to demand. It should be at the lowest possible point on that average total cost curve. Okay. If I then think about what's the monopolist choose, They choose a quantity where marginal revenue is equal to marginal cost. That price is above the price that we would see result from a perfectly competitive market. They have some positive profits. Right? Now, to draw a bit more of a simplistic view of this, I just want to get at, okay, if the quantity is lower from a monopolist, we said what's going to exist in this market? Similar to other things that we had, other government tools. So we said one thing the government can do is to protect industries and create monopolies. So if I'm creating a monopoly by giving them like patents, I'm lowering the quantity. What am I going to do to total surplus in the market? If I'm moving away from that perfectly competitive point, I would be moving away from the point where total surplus is maximized. Right? So let's start to think about what deadweight loss is going to look like. Okay? So just to kind of remove some of this to make it a little bit more simplistic, if I've got demand and we said the marginal cost, if I only have one producer, that represents supply. What is total surplus in the market? It's the difference between the marginal benefits and the marginal costs. And maybe instead of here, because I'll start doing monopolists, let's think about the total surplus in a perfectly competitive market. Okay? Well, that would simply be where supply is equal to demand, right? So what is total surplus here? What represents marginal benefits in my market? Demand. What represents marginal costs in my market? So total surplus would just be going all the way back to like module 5 and 6. No government intervention. Total surplus is simply the difference between the supply and demand curves. Okay? Now, if I have a monopolist, right, what is this going to look like? So this was just as kind of a reminder. Here was our perfectly competitive quantity. The monopolist is going to set quantity where marginal revenue is equal to marginal cost, which if we think about what is total surplus for the monopolist, what's still the difference between the marginal benefits and the marginal cost, still the difference between that demand and supply curve, but now they only sell up to this many units. So our total surplus now is going to be a smaller area, right? What are we losing out on? Because we have a monopoly exists in this market, or there's a firm with monopoly power, every unit in this range would have produced total surplus that was positive in the market, but the monopolist, it wouldn't have created any additional profit for them, right? The monopolist doesn't care about the market. The market takes into consideration everyone, producers and consumers. The monopolist is just choosing the quantity that maximizes profits, right? Or if it helps, this isn't quite synonymous, we'll talk a little more next class, but they're essentially maximizing producer surplus, not total surplus. So they don't choose to produce past this point. Every unit here, which would have had positive surplus, is no longer produced in the market. So this would all be surplus we're now missing out on, or this would represent deadweight loss. Okay? So when we have these markets monopolized, whether that's not, because they own a key resource or the government kind of protects them with a patent, we're still getting what in this market? Deadweight loss. So, people all right now are all very upset about quotas and tariffs. We said those do what? They limit the quantity and create deadweight loss. Now, nobody is up in arms about patents given to different companies, because what would patents do? They create a monopoly. No one else can produce that good. But what does a patent do? Lowers quantity and creates deadweight loss. Same thing as a tariff or a quota would do. Right? Now, what would the argument be for why a patent? So we don't really want to say those are the same thing. They could be. If I'm just giving patents out, like I'm Donald Trump and I give a patent out to my buddy because his company comes up, has something and I want to give them natural monopoly power in that market. Well, that's going to cause, it's the same thing as if I did a tariff or a quota. But why do we generally want to use patents? To protect what? New inventions or new products, right? Because if I come up with a product, I spend all this money and I don't have a patent, what is everybody else going to do? They're going to mimic it but they didn't have to pay all these R&D costs. So their costs are going to be much lower. They might be able to earn, in the long run, technically profits will be driven down to 0, but they didn't have to pay these huge fixed costs. If I did and profits get driven to 0, what are my profits? Whatever my research and development costs were, right? So we want to give patents to like protect these companies so they put money into coming up with new goods or new innovations, right? To have these new products in the market. If we don't use patents, so if we use them, what are we still going to create? We're essentially creating a monopolist, and we're going to have some deadweight loss in the market, right? But if I don't use a patent, if I know that everyone can just steal my new product once I come up with it, what am I going to do? Not come up with new products. So what happens to the market for these new products? It wouldn't exist. So if I don't have patents, nobody is incentivized to put money into research and development. What would my deadweight loss be here? The entire market, right? So it's better to have a little bit of deadweight loss than to lose the entire market completely, which is why we would probably prefer patents to the use of things like quotas, right? Or why they wouldn't have the same implications in the market. Because if I remove a quota, or if I, the market still exists. If I remove a patent, yes, if nobody else steals that company's technology, we would see deadweight loss go down. But if those other companies can just use my technology, what ends up happening, the market goes away, nobody comes up with these new innovative products. Now we've not just have a small deadweight loss from having a monopoly, we lose all of surplus because the market doesn't exist, right? So trying to kind of paint some of these bigger picture ideas, but ultimately what I want you to be responsible for here, and what we're going to end discussion with today, is just thinking about, because we have these monopolies existing, and this could be from government patents, could be that they own a key natural resource, could be because of the current cost structure only supports one firm, we will have deadweight loss in these markets. We'll think a little bit more about next class, what will consumer and producer surplus look like, and then talk about different types of monopolies, natural monopolies, government policy towards monopolies, and I might introduce a little bit of something on the labor markets that I won't expect you to know. So the slides say skeleton. I'm leaving out a few slides that we might look at the end of the next class if we have time, that I won't kind of have you be responsible for on that quiz or that exam. Okay? All right. So I will see you guys on Thursday.